Another group of chemicals used in cleaning agents is bleaches. Bleaches act very differently than surfactants that we've looked at so far, so their cleaning action is quite different than that of soaps and detergents. A bleach is used to remove a coloured stain, and it does that by acting as an oxidizing agent. So the bleach oxidizes the stain, and in doing so, it turns it from a compound which is coloured into a compound which is colourless. We're going to have a look at two different types of bleaches: oxygen bleaches and chlorine bleaches. The oxidizing agents in oxygen bleaches are hydrogen peroxide and oxygen. Hydrogen peroxide acts as an oxidizing agent under acidic conditions. Here we can see the half equation for the reduction of hydrogen peroxide. You'll notice that the electrons are on the left-hand side. That is, the electrons have been gained. Again, signifying that the hydrogen peroxide has been reduced. This is central to its role as a bleach because, if we remember from up the top here, bleaches function by oxidizing a coloured stain into a colourless substance. So if it oxidizes something else, it itself needs to be reduced. And we can see that here in the half equation. Another way that we can see that the hydrogen peroxide is reduced is by having a look at its oxidation state. Here, the oxygen has an oxidation state of -1. So you'll recall when you were learning about assigning oxidation numbers that oxygen generally has an oxidation state of -2, except when it exists in hydrogen peroxide. So this is the case where oxygen has an oxidation state of -1. If we have a look at the oxygen in the water that is produced, it's -2. So we can see the oxidation state has reduced from -1 to -2. Hydrogen peroxide also decomposes into oxygen, and the oxygen can act as an oxidizing agent as well. Oxygen can act as an oxidizing agent in both acidic and alkaline conditions. Again, you'll notice oxygen being reduced in both of these half equations. We can notice this by the electrons on the left-hand side of the equation, signifying that they have been gained by the oxygen. Also, we can notice this if we have a look at the oxidation state. So when oxygen exists at as a diatomic molecule, it's got an oxidation state of 0. When it is in the compound with hydrogen to form water, it's got -2. So we can see the oxidation state has been reduced from 0 to -2. If we have a look down here, we notice the same thing. Oxidation state of 0 on the left and -2 on the right. So in both cases, the oxygen has been reduced, which is central to its function because to act as a bleach, it needs to oxidize the stain. Just to recap what we've looked at so far, bleaches function by oxidizing a coloured stain into a colourless product. In oxygen bleaches, the oxidizing agents are either hydrogen peroxide or oxygen. Hydrogen peroxide can be an oxidizing agent in acidic conditions. It can also decompose into oxygen, which can be an oxidizing agent in both acidic and alkaline conditions. In chlorine bleaches, the oxidizing agents are the hypochlorite ion or hypochlorous acid. These are usually added in the form of a hypochlorite compound, which when it comes into contact with water can form hypochlorous acid. Out of the two, the hypochlorous acid is the stronger oxidizing agent. And because the function of a bleach is all about it oxidizing the stain, the stronger oxidizing agent, in this case the hypochlorous acid, is going to be a better bleach. So if we can, we want to push this equilibrium to the right so we've got a higher concentration of hypochlorous acid. One way in which we can push an equilibrium to the right is by removing one of the products. So if we lower the concentration of one of the products, the system is going to want to increase the concentration. So if we lower the concentration of hydroxide ions, it will push the reaction to the right in order to increase them. And by doing so, it will also increase the concentration of the hypochlorous acid. The way that we can lower the concentration of hydroxide ions is by imposing acidic conditions. In acidic conditions, there's an excess of hydrogen ions. Those hydrogen ions will react with the hydroxide ions to form water, effectively decreasing the concentration of the hydroxide ions. So essentially, a chlorine bleach is going to be more effective in acidic conditions because there'll be a higher concentration of the stronger oxidizing agent, hypochlorous acid, present. Hypochlorous acid is also significant when we consider chlorinated water. So this is a bit of a segue, but chlorine can be added to water for the purpose of killing disease-causing bacteria. And so many urban water supplies are chlorinated for this reason, to prevent illness caused by bacteria. On a large scale, this can be done by adding chlorine gas to water. The chlorine gas reacts with water to form hypochlorous acid. It's hypochlorous acid's ability to act as an oxidizing agent which allows it to kill bacteria. We'll come back to that in a minute. But for now, we'll just have a look. If we want to have a higher concentration of hypochlorous acid, again, we want to shift this equilibrium to the right. So in this case, again, we'll do that by removing one of the products. And in this case, that's the hydronium ions. So the hydronium ions indicate an acidic environment, so a low pH. So if we increase the pH, that means having alkaline conditions, it will neutralize the acid we've got here, essentially reducing the concentration of the hydronium ions or removing them, which will cause the system to push the reaction to the right to replace them. The pH greater than 4, the equilibrium is essentially 100% to the right. So with water with a pH of about 7, this equilibrium will generally be 100% to the right. So we'll get our highest possible concentration of hypochlorous acid. Because hypochlorous acid is a weak acid, it will partially ionize in water to form hypochlorite ions. The hypochlorite ions are also able to act as oxidizing agents and therefore kill bacteria. And they are referred to as free available chlorine. The disease-causing bacteria is killed by the chemical getting inside the bacteria cell and oxidizing the proteins that exist there. Hypochlorous acid acts best at doing this because it can pass through the non-polar cell wall with ease. The reason it can pass through the non-polar cell wall of the bacteria so easily is because it's a small molecule, and also because it is molecular, its lack of overall charge is of assistance with that non-polar cell wall. Once it has penetrated the cell wall, it can oxidize the proteins, which causes those proteins to break down, which will kill the bacteria.